Good morning everyone. In this session we will discuss the concept of kinematics of rigid body. So kinematics of rigid body, this is the part of module 5, and then we will solve the problem on the ICR method. So what is meaning of kinematics of rigid body? So if the velocity of the object depends on the size of the object, then it is referred as the kinematics of rigid body. Okay, so let us take this simple example. So we have the rod AB and it is fixed at this point. So this is the point of pivot, that is a point A, and the rod AB is rotating about this fixed point with the constant angular velocity omega. Okay, so the tangential velocity at the point B, which is a V, it will depend on the length of the rod AB. Okay, so we can write the equation. So actually this point B, it will follow the circular path, and the velocity V, it is a tangential to the circular path. So this is the example of the circular motion. So we can write V equal to, the basic formula is R into angular velocity omega. Okay, so for this case the radius of the point B will be distance AB, because this is the center point of the circle. So here V of the point B, this is equal to length AB, this is nothing but the radius, into angular velocity of the rod AB. It means that the velocity of the point B, it depends on the length of the object AB. Okay, now just consider this same example. So this is the point A, so this is the fixed point. Okay, this point is a B, it has a velocity V, or we can write here VB. Just take one more point, okay, in between A and B. So let's take this point as a C. So here velocity will be VC, and this velocity VC, again it will depend on the distance AC. Okay, so here VB will be maximum, so we can write VB, this is equal to AB into omega of the rod, because this is the angular velocity. Here angular velocity, it will remain same. Okay, only the linear velocity will change. So VC is equal to distance AC, which is the radius, into angular velocity omega. Okay, this is called as a kinematics of rigid body. It means that the velocity of any point on the object, it depends on the size of the object. Okay, now in the kinematics of rigid body, we have to solve the examples on the slider crank mechanism. So this is the schematic representation of the slider crank mechanism. So slider crank mechanism consists a crank OA. The meaning of crank is it has pure rotational motion, so it can just rotate, okay, like this. So this is called as a crank. Second is the slider. So this is the slider. So slider means it can just slide in this direction, to and fro direction. Okay, so it has pure linear motion. So it has a linear motion. Crank has a rotational motion, and there is one element or the object that connects this crank and this slider. This is called as a connecting rod. So this connecting rod, it has both the motions. So it has a translation as well as rotation. Okay, so this combination motion, this is called as a general plane motion. So the question will be, if the angular velocity of the crank is given, that is omega is given, we have to find out what is the velocity of the slider. Okay, and for that we have to use one method which is called as a ICR method. The ICR method is, this is the instantaneous center of rotation. Okay, so by using this method we can find out the velocity v of the slider if the angular velocity omega for the crank is given. Okay, so let us discuss all three types of motion in detail. The first motion is a pure rotation. So pure rotation means if the object has a fixed center. Okay, so let us take the rod AB. It is pivoted at this point. It means that point A, it cannot move. Okay, so just we can rotate the object with some angular velocity omega. Okay, so it can only have the rotational motion about the fixed point A. So this is called as a pure rotation. So you can take this example. Okay, if I fix this point, I can just rotate like this. Okay, so this is called as a pure rotation. So for the pure rotation, we can use the equation V equal to R into omega. Okay, so with this equation we can find out the velocity of any point. It may be point B, point C, okay, like this. So just we need the radius or the distance. Second motion, this is pure translation or the linear motion. So pure translation means, so let us take this object AB which is vertical. If I displace the object from this position to another position like this, so this is A dash and this is B dash without changing its angle, okay, then this is called as a pure translation. Again take the same example. If this is the initial position of this scale and if I move this scale like this, then this is called as a pure translation. Okay, or even if this is the initial position, if I displace like this, still this is the pure translation. Okay, it means that we are not changing the angle of the scale. So this is a pure translation. And the third motion, this is called as a general plane motion. So general plane motion, or in short it is a GP motion. The meaning is it is the combination of translation and the rotation. Okay, so here we can observe this type of motion. So the first example, it is a double slider. Double slider mechanism. Okay, so just consider this is the slider A and this is the second slider. Both the sliders, they are connected with one rigid rod. Okay, so this is AB. Now just assume the slider A, it is moving in the downward direction with some velocity. Slider B will move on the right side with some velocity. Okay, so after some time, if this is the initial position, so let us assume this is the initial position, this is the point A, this is the point B. So after some time, the slider will, the rod will change the angle like this. Okay, so it means that the complete rod, it is changing the angle, it means it has a rotation. At the same time, this point B, it is moving on this side. Okay, it means the slider has a translation motion. So if you observe the complete mechanism, it has both the motions, translation as well as rotation. Okay, so after some time we can observe so this is the new position. So this point is a B dash and this point it is the A dash. Okay, so if you see the angle, this is the original angle and this is the new angle. Okay, second mechanism, this is the slider crank mechanism. So in this slider crank mechanism, this crank, it is fixed at this point, so it has only rotation. Okay, so crank has only rotation. When this crank rotates in this direction, this slider, it will move on the right side. Okay, so it has only linear motion, that means it has a translation. But if you observe this connecting rod, okay, so this connecting rod, if the slider moves in this direction, crank rotates in the clockwise direction, this point A, it will move like this. Okay, so it has a rotation as well as translation. Okay, so therefore it has a general plane motion. So whenever any object has a general plane motion, it has a instantaneous center of rotation. Okay, so let us see how to find out that point. Okay, consider this double slider mechanism. So here this slider A and this slider B, they are connected with this rigid rod. Okay, this slider A, it is moving in the downward direction with the velocity VA, and this slider B, it is moving on the right side with the velocity VB. Okay, so after some time, this position, it will change like this. Okay, so it means that this point A, it moves in the downward direction like this, so it has only linear motion or the translation. The second point B, it is also moving in this direction like this, so it has only translation. But if you observe this rod, so this is the initial angle. Okay, after some time its angle will change. Okay, it means that this rod has rotation as well as translation. So whenever any object has both the motions, that is rotation and the translation, there is some hypothetical point which is called as a instantaneous center of rotation. Okay, so to locate that point, this is the slider velocity VA. So draw the perpendicular to this velocity like this, and this is the slider velocity B. So draw the perpendicular, and the intersection of these two perpendicular lines, it will give the ICR point. So this is called as an instantaneous center of rotation. Means that for a moment this complete rod, it is rotating about this hypothetical point. Okay, now just imagine after A point, the slider has moved to another location, that is A dash, and the point B, means slider B, it has moved to another location B dash. Okay, at this moment, where is ICR? So again, draw the velocity vector VA dash, draw the velocity vector VB dash. Now draw the perpendicular like this, and draw the perpendicular to VA. Now this is the intersection. Now this is the new ICR. So this is I1, this will be I2. Okay, so similarly, as the slider moves in the downward direction, this ICR point, it will gradually shift on the right side. Okay, so this is called as a ICR. Okay, so once we find out the ICR, then we can use the equation, and from that we can find out the relation for velocity. Okay, now consider this slider crank mechanism. Now in this slider crank mechanism, this OA, it is fixed at the point O, so it has pure rotation. Okay, so just imagine the direction of rotation is a clockwise like this, and it has an angular velocity omega. Okay, so OA is a crank. We have to first identify which is the crank. So OA is a fix at the point O, so therefore this is a crank, it has pure rotation. B has only sliding motion, so this is the slider. So draw the slider vector. If this is a clockwise, it means slider will move on the right side. So this is the velocity direction, so this is a VB. Okay, now the element AB which connects this crank and this slider, it has a general plane motion, means it has a rotation as well as translation. Okay, so for the AB, which is the connecting rod, so CR means connecting rod. Okay, it has somewhere the ICR point. So to locate that, first draw the VB and draw the perpendicular like this. Okay, now for the crank, first locate the velocity vector of the point A. Okay, so velocity vector of the point A, it is always perpendicular to this crank or the radius, and it is a clockwise, it means velocity will be in this direction. Okay, so this is velocity vector VA, and now draw the perpendicular to the VA. So their intersection, this point, it is nothing but the ICR. Okay, so in this problem, as this connecting rod, it is exactly perpendicular to the crank, therefore this velocity vector, it is along this connecting rod. Okay, so sometimes this angle is not 90 degree, then we can show the velocity vector like this. Okay, now refer this representation. So here OA and AB, they are not exactly perpendicular. So in this case, the crank OA, it has this fixed point, so it has only rotation, and this omega is the angular velocity. Okay, so velocity vector of point A, it is always perpendicular to this line, so we should draw this perpendicular like this. So this is velocity vector VA. Okay, and this is perpendicular to the line OA. Next, as it is a clockwise, it means B point, it will move on the right side. So this is the velocity vector of the point B. So this is VB. Okay, now draw the perpendicular to VB like this, and draw the perpendicular to the line VA. It means that just we have to extend the crank like this. Okay, and then we will get the intersection. This point is nothing but the ICR. Okay, so this is how we can locate the ICR point. After this, we have to use the equation. First use the equation for VA. So basic equation is V equal to, it is R into angular velocity. Okay, now first consider this point A, it is the part of crank OA. So we can write VA is equal to, R will be distance OA into angular velocity of the crank OA. So it is omega OA. Okay, so this is the first equation. The second equation we can write by considering this triangle. Okay, so VA, this is equal to R into omega. Okay, now here this connecting rod, it is also rotating like this, and therefore it has angular velocity in this direction. So this velocity is omega of AB, because AB is the connecting rod. Now write this equation as, for same VA, VA is equal to, now consider this R, as a distance from the ICR for the point A. So this is distance AI into, now take omega AB. So this is the second equation for velocity A. Okay, and the last equation we can write for VB. So VB is equal to R into omega. Okay, now VB, it is the part of AB, so we can write here omega as omega AB. Radius means radius with respect to ICR point, so distance BI, and this is a velocity of this slider B. Okay, so in the question, if omega is given, first we have to find out the velocity of point A by using this relation V equal to R omega. Next, consider the point A, it is the part of the connecting rod AB, and this complete rod AB, it is rotating about this ICR point. Okay, so use the second equation, VA is equal to, now here radius will be distance AI into angular velocity of the connecting rod, that is omega AB. From that find out this omega AB, and then use the last equation, velocity of slider VB is equal to R into omega. So R means distance BI and omega will be omega AB. Okay, so here the slider velocity, it depends on the initial parameter omega and the distance of the crank. Okay, refer the first question on the ICR method. So here one slider crank mechanism is given, and the question is crank OA rotates anti-clockwise at 100 rad per second. So this is the angular velocity. Then find the angular velocity of the rod AB, means connecting rod, and the velocity of the slider B. Okay, so the first step is draw the given mechanism as it is. So just we have to draw the line diagram, and then we have to find out the ICR. Okay, so draw the given diagram as it is. Okay, now here the crank OA rotates anti-clockwise at 100 rad per second. Okay, so here omega is given, which is 100 rad per second, and its direction is anti-clockwise, and this omega, it is for the crank OA, so this is omega OA. Okay, so this velocity, it is in the anti-clockwise direction, and the value is 100 rad per second. Okay, so here crank has a pure rotation. Okay, so first find out the velocity vector of the end point A of the crank, and this velocity will be in the upward direction like this and perpendicular to the rod OA. So draw this perpendicular like this. Now this is velocity of the point A. Okay, and the velocity of this slider, as this point moves in the upward direction, this slider will move on the left side. Okay, so velocity of this slider will be on the left side. So this is the velocity vector VB. Okay, now this connecting rod AB, it has rotation as well as translation like this. Okay, so this point B, it will shift on the left side, point A, it will shift in the upward direction. So the rod AB has ICR, so locate the ICR, draw the perpendicular to velocity vector VA, means extend the line OA like this, and draw the perpendicular to VB like this. So intersection point is nothing but the point I. Okay, now AB, it will rotate like this. So its angular velocity, it is in the clockwise direction. Now this is omega AB. This is angular velocity of the connecting rod AB that has general plane motion. Okay, now first find out the VA. So VA is equal to R into omega. Okay, now omega will be 100 rad per second and R will be distance OA. So right here OA into omega is omega OA. Now distance OA is given, it is a 200 mm. Okay, so this is 0.2 into omega is 100. So VA is equal to, this is 20 meter per second. So this is VA. Okay, now from the VA we have to find out the angular velocity AB. Okay, so before that we have to find out this distance AI, distance BI. Okay, for that some angles are given. So this angle, this is 40 degree, this angle is 20 degree, and therefore this total angle, it is 180 minus 40 minus 20, so this is 120 degree. Okay, so 120 plus 60 will be 180. As this is 120, so this total is 180 degree, so this angle will be 60 degree. This is 20, so this angle, this total is a 90, so this is 90 minus 20, so this is 70 degree, and this remaining angle, it is 180 minus 60 minus 70, so 70 plus 60, 130, so this angle will be 50 degree. Okay, now here in this triangle we will use the sine rule. So before that we have to find out this distance AB. Okay, so now consider the triangle OAB. So this point is O, this is point A, this is the point B, this is given as a point 2, this angle is 40 degree, this angle is 20, and this angle is 120. Okay, first we should find out the distance AB. So this is the unknown. Okay, so by using the sine rule we can write distance OA upon the sine of opposite angle, so it is sine 20, this is equal to unknown distance AB upon sine of opposite angle, so it is sine 40. Okay, now from that AB is equal to, let's do the cross multiplication, OA into sine 40 upon sine 20, so OA is a 0.2, sine 40 upon sine 20. So distance AB, this is 0.376 meter. Okay, now from this we will calculate the distance AI and distance BI. Okay, now consider this triangle. This point is A, this point is B, and this is the ICR. So distance AB is now 0.376. This angle is 50, this angle is 60, and this angle is 70. Okay, now to find out distance AI and distance BI, again use the sine rule. In the triangle ABI, so we will write distance AI upon this distance sine of opposite angle, so sine 70, this is equal to, now known distance is 0.376, sine of opposite angle, so it is sine 50, this is equal to, unknown is again BI upon sine of opposite angle, so it is a sine 60. Okay, now consider first two terms, do the cross multiplication, find out distance AI. So AI is 0.376 into sine 70 divided by sine 50, and now consider these two terms. So from that BI is equal to 0.376 into sine 60 cross multiplication divided by sine 50, this is equal to distance BI. Okay, so do this calculation. So AI is equal to 0.461 meter and BI is equal to 0.425 meter. Okay, so this is the first step. By using the geometry, either by using sine rule or cosine rule, we have to find out the distance AI and distance BI with respect to the ICR. Okay, and after this we will use the formula VA. Okay, now consider this point A, it is the part of this rod AB. Okay, so rod AB has angular velocity omega AB. Okay, and distance of A with respect to the ICR, it is the distance AI. So we can write VA is equal to R into omega, and now write here R is distance AI, this distance, into omega will be omega AB. So this is the second equation for velocity A. This is the first equation, VA, okay, which is 20, distance AI 0.461 into omega AB. Okay, so from this calculate omega AB. So omega AB, it is 43.38 rad per second, and then use the second equation for B, which is a VB. Again it is R into omega, but B, it is the part of this rod AB, so R will be distance BI into omega will be omega AB. So BI is 0.425 and omega AB is a 43.38. Okay, so from this VB is equal to, it is 18.44. Okay, so this is the final answer. So the slider velocity, it is VB, and the velocity of rod AB, it is nothing but omega AB, which is the angular velocity. Okay, so this is how we can solve the problem on the ICR method for the slider crank mechanism. Okay.